By now, we have understood how to divide a polynomial by another polynomial. So let's start our today's video by solving a problem. So we have to divide the polynomial f of x by the linear polynomial x minus 5. So let's do it. First, we multiply the divisor by x squared to cancel out the first term of the dividend. So by subtracting, we finally get the term as 10x squared minus 2x. Now, repeating the same process twice, we finally get the remainder as 240. So, when the polynomial f of x is divided by the linear polynomial x minus 5, the remainder is 240. Now, let's try a simple experiment. Let us substitute 5 in place of x in the polynomial f of x. Doing so, we will get f of 5 equals to 5 cubed plus 5 multiplied by 5 squared minus 2 multiplied by 5. Now, on simplifying this, we will get f of 5 equals to 240. Wait a minute. 240 is the remainder that we got when we divided the polynomial f of x by the linear polynomial x minus 5. That's an interesting observation, right? Now let's know how both of these two things came out to be equal. We know that the dividend is equal to the divisor multiplied by the quotient plus remainder. So we can express the polynomial f of x as the product of x minus 5 and x squared plus 10x plus 40 plus 240, which is the remainder. Now in this equation, if we substitute x equals to 5, then we can clearly see that the product of divisor and quotient is equal to 0 as the divisor itself is equal to 0. Since their product is equal to 0, we get f of 5 equal to 240, which is the remainder. This is why we got the remainder as the answer when we substituted 5 in place of x in the polynomial f of x. So here, when we divide the polynomial f of x by the linear polynomial x minus 5, the remainder is f of 5. This is known as the remainder theorem. The theorem says, let p of x be any polynomial of degree greater than or equal to 1 and a be any real number. If p of x is divided by the linear polynomial x minus a, then the remainder is p of a. The proof of this theorem is same as we did in the case of f of x. Let's say when the polynomial p of x is divided by the linear polynomial x minus a, the quotient is q of x and the remainder is r. Remember that r will be a constant since its degree must be less than the degree of the divisor, which is a linear polynomial x minus a. So here the degree of the polynomial x minus a is 1. So therefore the remainder r must always be a constant. So we can express the polynomial p of x as product of x minus a and q of x plus the remainder r. So p of x will be equal to x minus a into q of x plus r. Now in this equation, if we substitute x equals to a, we will get p of a equal to r. Therefore, we proved that the remainder when the polynomial p of x is divided by x minus a is equal to p of a. The remainder theorem will actually help us in saving a lot of time. Let us say we have to find the remainder when a fourth degree polynomial n of x is divided by the linear polynomial x minus 2. If we follow the long division method, then it will involve more number of steps, so it will take a lot of time. But if we use the remainder theorem, we can solve this problem just within 2 steps. So, to find the remainder when the polynomial n of x is divided by x minus 2, we simply substitute 2 in place of x. That is, we have to just find n of 2. That's it. Let's end our video by solving a problem. So in this problem, we have to find the remainder when the polynomial g of x is divided by the linear polynomial x plus 5. In remainder theorem, we saw that the divisor has to be of the form x minus a, where a is any real number. But here we see that the divisor is of the form x plus some number. So what do we do now? With the help of a simple logic, we can modify our divisor in our desired form, that is in the form of x minus a. So what we will do is, we will write the polynomial x plus 5 as x minus of minus 5. Now x minus of minus 5 is in the form of x minus a, with a being equal to minus 5, which is a real number. Now if we divide the polynomial g of x by the divisor x minus of minus 5, the remainder will be g of minus 5 by remainder theorem. If we calculate g of minus 5, it will be equal to minus 348. So the remainder when the polynomial g of x is divided by x plus 5 is equal to minus 348. So friends, that's all for today. In our next video, we will be learning another interesting theorem known as factor theorem. As of now, let's summarize what we have learned so far. The degree of the remainder must be less than the degree of the divisor. Let p of x be a polynomial of degree greater than or equal to 1 and a be any real number. If p of x is divided by the linear polynomial x minus a, then the remainder is p of a. Dividend is equal to the product of divisor and quotient plus remainder. In the remainder theorem, the divisor must be of the form x minus a, where a is any real number.